What's up, guys? This is FTC22012. In this tutorial, I am here to help you guys understand thresholding and easy OpenCV. This is the first video of many to come in our OpenCV tutorial series. So what exactly is thresholding? Well, a threshold is a minimum value. This number represents the smallest value that a pixel must be to be deemed as a certain color. Different ranges of values can be associated with different colors. In easy OpenCV, a maximum value must also be present to make sure that the code doesn't get every color above the threshold. What a thresholding algorithm does is that it compares each pixel in an image and tests if it is within the lower and upper bound that is specified. If it is, then it sets that pixel to a white color, and if it isn't, it sets that pixel to a black color. This results in a black and white image that contains all of the pixels that are a certain color, or in the range. Now, each camera or webcam usually captures an image that has pixels in the RGB color space. However, RGB tends to have problems with different lighting conditions, and it is kind of hard to define ranges. That is why in Easy OpenCV, we typically use the HSV color space. The HSV color space is easier to deal with because you can deal with different lighting conditions, and I guess you could say it's easier to define ranges. Here's an example on Android Studio. Let's say we're trying to detect the color blue in an image. We can start off by defining the lower and upper bound for a threshold. This can be done through the scalar class. The values for the threshold can be found online, or one could manually determine them using an HSV color wheel. In Easy OpenCV, the range for the H in HSV is from 0 to 180, the range for the S in HSV is from 0 to 55, and the range for the V in HSV is also in 0 to 55. So we have to do some math to convert the values into that range. The values for the lower blue is 85, 50, and 40, and the values for the upper blue threshold is 135, 55, and 25. Now we have to convert the input image from the RGB color space to the HSV color space. This can be done by defining a mat to store that HSV input frame, just like this. And now we can convert it using the IMG class. Using the function CVT color, we can give it an input, the destination, and the code, which is also in this class, which is just, you can just type in RGB to HSV and then hit. Now that it's the HSV value of this input frame is stored in HSV map, we can now apply the threshold. This is done using the core class. But first, we have to initialize another mat to store the threshold, just like this. Now we can apply the threshold using the core class. Now we can put the lower and upper values of the threshold. And all we can do now is we can just return threshold. And we are done. Here's another example in Android Studio, but for the color yellow. So we can start off by defining the lower value for yellow. The values for this are 20, 100, 100. And for the upper, they are 30, 255, and 255. Now, just like before, we can make a HSV mat to store the HSV values of the input frame and then convert it using img.cvt color and make sure to give it this code. And now we can store the threshold in a new mat by defining it first and then using inRange and giving it the threshold values. And we are done. Here are the outputs for both segments of code. I used an image of a blue bag that I found off the internet, and I found a picture of a banana as well. A common issue that arises involves a threshold image being completely black. A simple fix may involve changing the RGB to HSV to BGR to HSV because sometimes webcams and cameras load the image in BGR format instead. Stay tuned for the next video in this series about cropping, and thanks for watching. See you next time.